Jai Mata Di guys. Let's calculate power for a two-stroke engine. When I talk about power, again guys, before going through this unit, please go through my section of that power and atmospheric pressure which I had made you study earlier. Power is work done upon time. Work done is force into displacement upon time. Hi GME aspirant, Jai Hind, Jai Bharat, Jai Mata Di. I hope you like this video. One thing that you have to remember is that you have to join top-notch shipping company or college with sponsorship and in the shortest time possible, because time is money and time kabhi वापस नहीं आएगा. Now guys, I have got two suggestions. One is GME live classes. Enroll, fantabulous results. घर के comfort zone में बैठ के पढ़ाई करो. Another is 100% results, shortest time possible. Join SMBD Marine Academy offline coaching. Jai Hind, Jai Bharat, Jai Mata Di. Link सबके डिस्क्रिप्शन बॉक्स में. Let me draw. This is my exhaust valve, and say over here is my piston. Scavenge ports are over here, and the liner is septal here. Okay. Now, power is equal to force is pressure into area into displacement upon time. Now when I talk about this area is the area of the liner. That is, if the bore of the liner is diameter d, then area will be pi by 4 d square. So you know what is a bore? Bore is the diameter of the liner. Okay? So area becomes pi by 4 d square. What is displacement? Is the distance travelled by piston from BDC to when it reaches TDC. Suppose at BDC piston is at over here, and when it reaches TDC it reaches over here. So this is the displacement, and it is also called stroke length. So it is denoted by L in meters. Okay? Area is also in meters. So now power becomes pressure into area is pi by 4 d square into L upon time. Say 1 second. Okay? I'll take it at 1 second. Clear? Now what is pressure over here? Pressure is the gas pressure or the after explosion, whatever pressure is acting on the piston downwards. So this pressure is minimum when the piston is at BDC and maximum when the piston is at TDC. But understand one thing, that your pressure is changing throughout the cycle. When piston moves from here, it starts increasing, and then again it starts decreasing. Right? So basically, this pressure is not constant, it is changing throughout. So you need an average pressure which is acting throughout the cycle. Because over here it is say 1 bar or 2 bars, and over here it is 100 bars. So it reaches from 2 to 100 and then again from 100 to 2. So you need a pressure which is constant throughout the cycle, and you have to calculate that. So we will calculate that. I will show you the method, but that is called mean pressure, P mean, average pressure into pi by 4 d square into L upon say time, which I will take as 1 second. Now let's just forget about P mean and let's just talk about time. Now suppose your engine is running at 60 revolutions per minute. Understand one thing guys, that power is being generated when explosion takes place, right? So in every revolution, each unit is generating power once. When in a two-stroke engine, when an engine rotates 1 rpm, in that 1 rpm, all the units have fired once. Right? So that means to say, if it has got 60 revolutions per minute, that means if the propeller is running at say 60 revolutions per minute, that means 1 revolution per second. That means to say each unit is generating power just once. So that means per second means nothing will come over here. This is L. But suppose your engine is running at 120 revolutions per minute. That means 2 revolutions per second. This means to say in 1 second each unit is firing twice. That means to say in 1 second each unit is developing twice the power. So this should be multiplied by 2 in that case. This means that power is P mean into pi by 4d square into L into number of revolutions. Per second. Right guys? So, because we need time per second, this is how we get power in watts. And if you divide it by 1000, you get in kilowatt. You divide it by 746, you get in brake horsepower, bhp. Copied guys? So this is something we have to know. Now the only thing that is remaining we do not know is how do we calculate P mean. Right? So that Jai Mata guys. There are 2 curves that I made over here. Now you guys might find it, yeah, it is not related. Yes, it is related. But again I would say ki in the interview, see, these questions are not going to come in your online test for sure. But in case if it comes in interview, read carefully, walk carefully what you are going to say. Either be 100% sure or say clearly, sir, this much I know, I really do not know whether it is correct or not. Because as a chief engineer, it has taken me years to get this knowledge. So it is not possible for a person who is in mechanical engineering to have all those things. Moreover, I know these things, I have done these things practically, so knowledge is different. So, no worries, just know this can become your passing question so try to understand that way. Okay? I have got, this is a draw card. And this is a power card. Now when I talk about power card, you know power is work done upon time, and in the PV curve work done is the area inside this curve. That is the work done. Okay, fine. Now out here when I talk about power card, again we connect the indicator cock and we take, there is a thread which is moving because we want this to be in sync with the engine. Over here engine is at below the scavenge ports. It starts moving up, pressure starts increasing, reaches TDC, maximum pressure, and then after that combustion has taken place out here, and then it starts dropping also. It is a bit like banana shape, not a very good diagram again, but as a layman I am trying to explain you. So over here, your draw card, over here, your indicator instrument is connected to a cam below. To a cam. It is a separate cam fitted. Like say, this is your engine. Again, this is your indicator cock. Now this indicator cock out here is connected to a separate cam. So when you connect it over here, when this cam moves up and down, this is not the camshaft with which your fuel pumps and exhaust valves are connected. A separate cam is there. So when this rotates, it immediately moves along with as the piston is moving up and down in sync with that. So you get this diagram. Clear? Fine. So now when you get this diagram, what you have to do is over here, I hope you remember I did not get P mean. So over here I need P mean. So how I get P mean is, I say I calculate this area and divide it by the length of this curve. Area of curve divided by the length of the curve. Say this area is x. Okay? If I divide by this, I get a pressure P mean over here, which will be going to the same length like this. And if now this becomes a rectangle, if I calculate the area of this curve, it will also be x. So work done will be the same. But I have got my constant pressure which is going to act throughout the cycle, and I put it over here in bars. So this is how I get my power. Okay guys? Now when I talk about this draw card, this is not over here. In this case this thread is not connected to the cam. It is in your hand and you do it yourself. This comes with a lot of practice guys, and you calculate it. Okay, now the engine is coming up, I have to calculate something like this. And you get this curve like this. Now not a lot of importance what I talked about earlier, how we do this, how we connect this indicator card. But if at all you can explain this, you can make this diagram. You can make this diagram. And you can tell me what is this, what is this. Okay, how you get P mean is more than sufficient guys. That is more than sufficient. Okay. So out here, see what is happening. Engine is going up. Engine is going up. Air is getting compressed. Out here, this is the maximum pressure that I get over here. This is called compression pressure. This is called P compression. Okay, because till over here, air is being compressed. Now, you see over here, the pressure drops slightly. Why? Because this is the time when fuel has been injected in. Now once the fuel goes in, fuel is slightly cooler than the air inside, so the pressure drops a little. Over here, pressure drops and suddenly combustion, BAM! Takes place and the pressure immediately starts rising. Right? And you get the maximum pressure over here, which is called P max. And after that, the pressure starts reducing. Sometimes from this curve also we can make out whether the engine is running properly or not. Now suppose you have got a curve, ideally it should be like this, but you get a curve which is like this. So basically P compression and P max is less. But out here you see P compression is less, that is why P max is less. First of all, this has got less now. After that fuel is being injected. If this is less, automatically this is going to be less. Now P compression is less. That means my air is not developing that much pressure when it is being compressed. So maybe scavenger pressure is less. Maybe air inside coming is less. Maybe my piston rings are broken and my piston rings are broken, and when I am compressing it, air is leaking down below over here. Maybe my exhaust valve is leaking slightly and air is going out. That can be the problem. Now suppose you get a curve like this, same P compression, but your P max has reduced. That means till compression side, till air side, everything was okay. But now when fuel is entered, pressure is not developing. Something can be wrong with the fuel pump. Is the fuel of good quality? Okay, let me check off other units as well, because the same fuel is going to all the units. If all the units P max is coming less, that means problem is with common, that is with the fuel. But if for one unit it is a problem, that means maybe the problem with the fuel injection pump, maybe the problem with this unit's fuel valve, maybe the problem with this fuel unit's fuel nozzle of the fuel valve. So you have to find out, and this also gives you an indication. Clear? Now I forgot to tell you one thing, guys. How do we calculate this area? And we calculate this area by a device called planimeter. Now this is something that you have to remember. If at all you make this diagram and you tell me, sir, I have to calculate P mean, so I know I get a power card like this. So I need a constant pressure because the pressure is changing throughout the cycle. So I will calculate this area and divide by the length. I will get P mean. So you say, how do you calculate the area? You say by a device called planimeter, sir. But this is only this much is only what I know, sir. Not much. Okay? Clear? This is more than sufficient if at all you want to tell. Now, let me talk about 4-stroke engine power, how to calculate. Okay, wait. So now, in a 2-stroke engine, we know that power is P mean into pi by 4 d square into L into n by 60, number of revolutions per second. Now what happens is, in a 2-stroke engine, for one crankshaft rotation, every unit is firing once. But when it comes to 4-stroke engine, for every unit, for every revolution, each unit is firing half time. Right? So what happens is, in case of power, this is 2-stroke. In case of power, 4-stroke, it becomes P mean into pi by 4 d square into L into n by 60 into 2. That means it becomes half. Clear, guys? Now this is something important for you guys to know as well. Now another thing is, see, the challenge is going to be in a 4-stroke engine. Now let me compare main engine, which is a 2-stroke, and auxiliary engine, which is a 4-stroke. When I talk about on ship, yes, main engine power is calculated like this. But these days we do not use this tedious method of doing it with the indicator diagram, everything. Everything is electronics these days. So we use a device called PMI. It is an electronic device. You take it over here, a sensor is there. You fit that sensor on the each unit's indicator cock, and it will automatically calculate P, mean, power, everything it will calculate itself. And you just have to feed the readings. So things have become very easy. Sometimes these PMI can be used in some cases on the auxiliary engines as well. Automatically you get. Okay? Now in case of auxiliary engines, the problem that we get is it has got a higher RPM. Say main engine is rotating at say 120 RPM, 140 RPM. On the other hand, auxiliary engine is rotating at 700 RPM, 900 RPM. And most importantly, the stroke length is small. Main engine is a 2-stroke engine going like this and coming up. 4-stroke is simple. So getting a power card becomes difficult. So out there, what we do is, in auxiliary engine cases, Either company should provide us with an electronic PMI where we can get everything exact, and in case they have not done that, then in that case what we do is we calculate the peak pressure developed by the auxiliary engine. So what we do is we connect an instrument which has got a gauge fitted over here. Okay, so it has got a piston over here. So when I suppose this is the indicator cock, this is threaded, so I put a device over here like this, and I put a piston over here like this, which is moving up and down. I put a spring pressure over here, and over here say I connect a pressure gauge. So when this piston moves up and down, along with this pressure gauge reading will move up and down. So this pressure gauge reading will show us, okay, inside pressure is 110 bars, inside pressure is 120 bars, that is P max. So in case of generators, we run it at the 85% load, say, we get all the P max, that is the maximum pressure being generated inside, and we know one thing, if maximum pressure generated inside is same, that means your P compression is also going to be the same. And you see all the units, exhaust temperatures, cooling water temperatures, lube oil pressures, and then you get a very good idea that my engine is running in good shape. Clear, guys? This is important. Now, when we calculate power, once we have got power, the power we get in kilowatt, right? Now let's come back to two-stroke engines. Okay? We have got power, we have calculated in kilowatts. Now what we do is, we run this engine for 1 hour. What we do? We run this engine for 1 hour at this RPM. Or I mean to say higher load where we take the performance. Clear? Now what we have to do is, guys, we have to calculate SFOC, which is called specific fuel oil consumption. See, we want to know that how much gram of fuel are we burning to get this much energy. And energy is kilowatt into hour, kilowatt hour, right? So SFOC is grams per kilowatt hour. So how we do that? When we run this engine for 1 hour and we get the power, in the meantime we also get the flow meter readings. So we know, okay, the fuel burnt has been, say, 1 meter cube. We know the density of the fuel. Yes. So if we know this volume and we know density, can we know the mass? Yes. Can we get that mass in grams? Yes. We get this mass in, say, kg. We multiply it by 1000. We get that mass in grams. And then we divide it by this power, kilowatt. R remains the same. And that is how we get this SFOC. And this SFOC, when we calculate and we compare it with previous readings and with the readings when our engine was new, and that is how we get a very good idea how our engine is performing. Copied, guys? Now this was very important for you to remember. Copied? Thank you very much. Jai Mata.